All right, here we are. This is Mr. V. What we're going over today is assignment A4, which is asking you to write a short little program to convert a Fahrenheit temperature into Celsius. We might want to go the other way as well. So where I typically start when I'm writing a Java application is I go to the File menu and I say New Project. And the project we want to use is, or the setup we want to use is this one, Java with Ant. And it's a Java application. What's nice about this is it sets up the project for you. You don't have to do it yourself. And it also creates a main method for you. So let's take a look at that. All right, so looking here at our assignment, we can see that we need to create this class. Here's the equation. It looks like there's already a video out there on how to do this. So what I'm going to do is jump ahead then to assignment A5 and A6, which is to create a library of these kind of conversion routines. Not only do we want to go from Fahrenheit to Celsius, but also Celsius to Fahrenheit and some of the others. So let's move to that one. Just going to the assignments and taking a look at the next one. So we were here. Let's see, where are we? One of these. Here we are, conversion class. All right, so let's look at this assignment. There's a video there that describes how to complete the next assignment as well. But we're going to go over that using the newer version of NetBeans and things like that. So we're going to take what we learned already about Fahrenheit to Celsius, but we're going to apply it to Celsius to Fahrenheit, and then all these other conversions as well. There is a presentation that goes over what we're trying to do, so we're going to quickly look at that and click on that and take a look at it. All right, here's our slideshow. So sometimes when you're writing Java applications, you're not asked to actually write an application. You're asked to maybe create a set of methods that can be useful in other programs, but the library itself does not have a main method. And so that's what we're going to do here with our metric conversion functions. Let's take a look. This idea of code reusability, a lot of people think you write code from scratch all the time, and that's not really true. Typically what you're doing is you're taking code that's already been written and you're reforming it or reusing it in a way that maybe it wasn't originally designed for, but it's still useful in this other project. So these, there are times when programmers want to use the same set of classes in more than just one program, so we set up a Java library to do that. Code reuse is an important strategy when you're working with large computer projects. It helps you save money, right? You don't have to keep writing from scratch. You can use stuff that you've already created. But the key thing is to when you design your code, make it so that it's easily reusable, and that's a little bit harder to do. But we're going to try to do that today. Now we're going to have a lot of perhaps upcoming projects where we require this ability to convert from metric to standard English measure. Instead of just taking the code from the project and copying from place to place, it would be better to put it in just one place. It's a folder in the way Java works, where you can put your library so that all the projects you create, you can use that same library. So libraries are a little bit different because they don't have a main method inside them. They have to have an application that loads that library, and then the main method from that application then can use the methods that are found in the library. So we're going to try to make one of those ourselves. So what's needed is a conversion class project, and we're going to modify it to the new structure. Actually, here in the video, we're just going to start from scratch. So we're going to make a metric conversion library project, and then we'll create a new package called metric conversion, and then we'll type in again what's supposed to go into that conversion class. We'll start with Fahrenheit to Celsius, but then we'll add some of the other ones, and then show you how to go about doing that. Here's the things that we need to make. This is an important slide. all the things we need to make. These are all going from one to the other and back again. So here's Fahrenheit to Celsius, Celsius to Fahrenheit, inches to centimeters, centimeters to inches, miles to kilometers, and so on. For a lot of these, there isn't actually an equation that you use to do the translation, and we'll see that coming up. There's equations you can use for these first two, but then the rest of them, we're going to use something called the scaling factor. We also need a kind of multi-purpose method for rounding numbers. So here's a little method for doing that. Because when we show these temperatures or these quantities, I guess, we only want to show up to 2 decimal places, and we want that last digit to be rounded. So this is how you might go about doing that. We'll add that to our system. In fact, I'll copy it now so we can grab it. I don't have to remember how it goes. I'm copying it. Okay, so back to our assignment then. We've got to do all these things. There's our presentation. Where to start? Well, we're doing something a little bit different this time. So let's jump over here then. Oh, not that. No, I want to jump into this, right? Now, normally we would create a new application, but we'll do that eventually. But for now, we just want to create the library. So instead of creating this first one like we normally choose, we're going to choose the second one, or it might be in a different order depending on what you've done. But we want to choose this one, Java Class Library. That's what we're creating. And we want to give it a meaningful name. So I'm going to call it, metric conversion. Yeah, I already have one of those. So I'm just going to call mine metric conversion 2. Yeah, it looks like that was there already too. So let me call it metric conversion 5. Or how about we'll put the year on it, 2024. It's the year I'm making this. Yeah, that one hasn't been used yet. But you can just use that metric conversion. I do this one a lot year after year, so that's why I keep running into name collisions. All right, let's try it. So we say finish, and what you're going to notice here is that you go into the source packages, you notice there's nothing there. Normally when we start an application, at least we have a main method. Here we have nothing. There's no files at all in this package. Do we have to create a package first? I guess we do. So how do you do that? I guess you right click and we say new Java package, I guess. So let's try that. What are we going to call this? We'll call it metric conversion. Notice how on our package name we're keeping all the letters lowercase, and that's the standard that NetBeans does. I'm not sure why they do that, but that's what we're doing. Say finish, and it creates that package for us there. Now we have a name for it, and now we want to add a class that will just contain all of our methods for doing metric conversion. So we're going to say create new, and this time a Java class. What are we going to call this one? Metric conversion, I guess. What should we call it? Metric conversion is more like a verb. What we really need to do with this class is give it a noun kind of sounding word. So metric converter would be better. So I'm going to change it. So our package is called metric conversion, but our actual class name is called metric converter. So now we say finish. And note we've got basically a class called metric converter. And we have this stuff at the beginning. I'm not using these. It's part of the Ant script built in. I should probably change that one of these days, but I just delete it, get it out of the way. What you should have then left over is a package name, the author, and then metric converter. Now we'll get into more about what these weird these comment frames are. We'll use them later, but here we've got to add in our first method. Now we already have this one in the last assignment, but it should look like this: public static. I guess is it static? I suppose so. Static, and then we want this to return a double, so we say double, and then we call it F2C. Kind of weird looking that way. Normally you'd want to use a capital F, but because this is not a class name, we use a lowercase f. And then we see that this F2C method is going to return a double. So when you see the word double there, it tells you what type of number is going to be returned back. What do we need to convert a Fahrenheit temperature to a Celsius temperature? Well, we need the Fahrenheit temperature, I guess. So we're going to say double. I want to call this one F-temp for Fahrenheit temperatures, because we're trying to get from Fahrenheit to Celsius. The output from this method is the Celsius temperature, but we're passing in as a parameter the Fahrenheit temperature. Kind of makes sense. You're trying to convert from Fahrenheit to Celsius, so you pass into the Fahrenheit one, and it gives you the Celsius one. Okay, so now we hit enter, and now we have to provide the body of the method. And so I put an open curly brace. Zoom in a bit, because sometimes on these videos they get a little bit small. Doesn't look like an easy way to zoom in, so I guess you could probably do that on your own computer. Okay, so now we have to put in that equation. Well, what was that equation again? Let's look at the equation. Going back. So we're looking at this equation. I seem to remember that this is purposefully misleading, but we'll find out soon enough. Okay, so here's our temperature. How do you convert a formula then to some code? We paste that in here. That's not going to work. We've got to somehow convert this into programming code. So maybe we use that as a comment. I put an end line comment. That's the equation we want to kind of mimic. But we could say, you don't have to do this, but this is something I normally do on this first one, is I create a return value. I say double return value. This is the value you're going to return as the result of doing this method. And I don't initialize it because I don't think I need to. Now it complains right away. It says, hey, you made this variable and you're not using it yet. Well, of course not. I'm still just writing it. A lot of people get really upset right now going, how can there already be an error? I just put the thing in there. It's because we haven't used it yet. It's not really an error. No, it's just a warning. But there's an error down here saying, hey, you're missing a return statement. We'll get to that in a second. Okay, so the thing we're trying to calculate is the Celsius temperature, and we want to put that into the return value at the end of this. So then we want to say return, and of course, what do we want to return? The return value, the one we just figured out, except we haven't figured it out yet. So here it's a little happier. Well, I think it's a little happier. Why is it complaining? Variable return value might not have been initialized. Yeah, we haven't done the processing part. So how do we convert this F-temp then into a Celsius temperature? Well, we need a place to store that Celsius temperature, and that's going to be the return value. So we're going to say return value. This is the value returned from this method. See right there where it says double. That's the value that's going to be returned. And we're going to set it equal to this equation. How would you write it in Java? Well, F-temp we have, so we can use the parentheses. We can say F-temp, and then we can say minus 32. So we subtract 32, and then we multiply it to the way you do multiplication in Java is just using an asterisk. And then you say 5 divided by 9. Okay, and then a semicolon. And you say, well, yeah, that looks pretty good. That's the equation, all right. We've got the Fahrenheit temperature and Celsius. We switch sides, right? Because what's weird about programming is the equation goes on the right side and then the variable goes on the left. So it's always going from right to left. You do this equation and store it in the variable on the left. And then we can just return that return value. Seems pretty simple. Well, yeah. It might seem simple, but there's some problems here. First of all, how do we test this to see if we get the right answer? We don't have a main method to call. There isn't one here in this metric converter thing. I guess, let's create, I guess to call this, we have to create another package. Or call it new Java package. And we'll call this one, I guess we'll call it metric tester. Okay. So again, a noun. You want to choose a noun for these things. Say finish. So we got this metric tester package, and then inside that we want a new class. And we could just call it metric tester. So let's try that. Metric tester. Say finish. So when we're done, we have two packages. One is going to serve as our library, right there, metric converter, and the other one is going to serve as our place to test it. So in order to test it, we need a main method. So public static void main, and then in parentheses you put string with square brackets r. If you're going to memorize anything in Java, it's probably this line of code, because it has to be in every Java program. This is the starting point for every Java program, is to add that main method in the program. Now that we have a main method, we can actually call these methods inside the metric converting class. Let's see if we can do that. Say we want to take a value. Let's say there's a certain numbers that when you convert from Fahrenheit to Celsius, you should get a specific number. Like if you say 32 in Fahrenheit, well, remember in Celsius, 0 degrees, it has to do with water, right? The freezing point of water is 0 degrees. The boiling point of water in Celsius is 100 degrees. Okay, so that's your range. But that's different in Fahrenheit, so we can try those numbers out. So let's say, for example, we say system.out.println, and we want to say, well, we're going from Fahrenheit to Celsius, so we say the temperature in Celsius well, maybe we want to say, oh, what temperature we're sending in. So maybe we make a variable. And we'll make this a double, and we'll say, we'll use that same name, ftemp. This isn't the same variable, however. You can actually call it anything you want here, but I'm just going to call it ftemp to be consistent. And we'll set ftemp equal to 32.0 because it's a double. I always put the 0.0 at the end, and we'll talk about why here in a bit. But the temperature, and maybe a space here, and you can say the Fahrenheit temperature. Hardest thing about this is how do you spell Fahrenheit? Fahrenheit. That's how you spell it. I think it's German. Temperature, and then we might add on that temperature ftemp. ftemp, and then maybe another plus sign. We're just pasting these things on. Is another space. And then we want to say what the Celsius temperature is. So we say, well, we can just call the method. So the method is called F to C, right? F to C. And we pass in our Fahrenheit temperature again. Right? And it complains. Right? It says, well, wait, I don't know what F2C is. F2C. It's not in this class called metric tester. It can't find it. And the problem is because we haven't, since this is in a different package, this project can't see it. I mean, this code here cannot see that code unless you actually import it. So let's try that. I'm going to right click. Well, it doesn't really give us, not trying to do breakpoints. I guess I'm clicking on it. So do you want to add an import for this? It sees it over in the metric conversion class. You don't want to do this one ever. Create a method. No, we've already created it. It's already there. So you want to choose this first one. Add import for metric conversion.metricconverter.f2c. Oof. So it adds that. This is kind of interesting. Notice they've included the word static. That's the first time I've seen that. Not sure why they would do that. But anyway, now we've loaded that F2C method. And we can try this out. Now, before we run this, we want to say, well, what do we expect the answer to be? Well, we know that 32 degrees in Fahrenheit, which is the freezing point of water, should be 0 in Celsius. So let's see if we get a 0 coming up. We'll try it. It can't find the main method. It's really having a problem. Why can't it find it, you would say? There's one right here. We just made it. We're trying to run this thing. If I say run again, it still can't find it. Not very smart. What you can do is you can right click where you know the main method is. We know we have one here. And we can just say run. And now suddenly you can see it. Notice I put a little triangle, green triangle now, because you can see, hey, there's a main method there. And it says the Fahrenheit temperature of 32 degrees is 0. Well, that sounds correct, right? We got 0. Let's try the boiling point of water, which is 212 in Fahrenheit. What is that in Celsius? And we run in and we get, oh, it sees it now. So we say okay, because it found the main method, and we get 100, and it worked. Now, I was expecting it not to work. So this didn't really match my expectations, right? I was thinking that this would fail, especially right there. Let's think about what order we'll do this. There's an order of operations, just like in math class. What does it do first? What does the parentheses first? We take ftemp, which is a double, and subtract 32 from it. But because it doesn't have a decimal point or a 0 after it, that's an integer. But because this is a double, this gets promoted to a double behind the scenes. And then you do the math. And since this is a double, then it multiplies it times 5. 5 is an integer, it doesn't have a 0.0 on it, but that gets promoted to a double. So that works. And then it divides by 9, but since all of this is a double, you divide it by 9, and that 9 gets promoted to 9.0. So we did actually get the right answer, surprisingly. Now, if I was going to be a little bit more stickler about this, I would put in a 0.0 on all of these numbers just to make sure that the compiler does what I want. I want all of these things to be doubles. Okay, so now we have doubles everywhere. Hopefully we still get the right answer, and we do. But say we put in a kind of a weird number. Say we put in a number in our tester, at least up here, we change it to, I don't know, 70. Right now, the temperature in our classrooms isn't very good. So we had 78 the other day in our classroom because the air conditioning system's not working. So what is that in Celsius, I wonder? So I run it, and I get really ugly output. 78 is 25 point, lots of fives, 7 for some reason at the end. And so doesn't look very good, and it doesn't tell us. We're missing the word Celsius too, right? So we want to say, maybe we're not quite complete here yet. We want to say plus in Celsius. Celsius is spelled weird, I think. Okay, let's try that. I guess it's a sentence, so we can put a period on it. Try again, and again it looks really quite awful because we have all these things. We're not going to that level of precision. We're just trying to get an idea of what the temperature would be. Say you're not from the United States and you're trying to see, well, what is this in Celsius? 25 is pretty warm, especially indoors. So how do we make that look nicer? Well, remember I told you about that. Remember we were looking at our where was it? It was our presentation, right? See this one? We need to have this one somewhere in our program. So let's do that. All right. Where would we put it? Should it go in the tester? The answer is no. Maybe we put it in our metric conversion class just as a little helper function or method. So we go into the metric converter, and then we're going to add another method down here. And that's our little rounding method. I'm just going to paste it there and get the indentation right. It says private. That would be very helpful if it's private, but it's saying round is never used. Well, we probably want to round it before we give it back. So we could say, we could say it right here. We could say round. And then, so whatever we get back for our return value, we round it before we give it back to whoever called this method, right? And so I guess it's okay for it to be private. You might want to use it, if you might want to use it outside of the metric conversion function, you would switch that to public, and we might do that later. But right now, private is fine. It's only available inside this class for use by the other methods in this class. Let's see what it looks like now when we run it. So we run it, and yeah, there we go. We've got it rounded, and it looks nice. So 78 is 25.56 in Celsius. We get a nice looking output to our method. And we kind of tested it. It seems to work okay. We're getting the right answer, hopefully. So now how do we go back the other way? Say we want to go from Celsius to Fahrenheit. Well, let's just copy this. It's very similar. But the problem is it gets really complicated or really confusing because we're going from one thing to another. We're going a different direction. So what do you have to change when you flip it around like this? Well, first of all, it complains because it says, hey, we already got one of these F to C. Well, we're going to change this one to C to F. But you have to keep in mind, what is your input and what is your output? Our input should be the Celsius temperature, and our output should be our Fahrenheit temperature. So instead of a Fahrenheit temperature coming in, we're actually needing a Celsius temperature to come in. So I'm going to call that C temp. That's just the name I'm calling it. But just so I know that's the Celsius temperature, not the Fahrenheit temperature. How do we undo this? How do we do this equation backwards? Well, this is not the right equation. How would we make it go the other way? Well, I think you do the 5/9 first, but I think you got to flip it over. So I think what you say is you take the Celsius temperature, there's Celsius, and then you multiply it. What you do is you take the reciprocal, I guess, and we're going to say, we're going to take C and we're going to multiply it times 9 over 5, because we're flipping it the other way, I guess, right? And then when we get done with that equation, then we want to add 32. And that will give us our Fahrenheit temperature. Okay? So I think that's the equation we need to do. So we've kind of flipped everything around. So our return value is still a double, but that's going to represent the Fahrenheit temperature. What we're passing in is the Celsius temperature. So how can we express this equation using Java? And so let's change this first to C temp, because that's our input, right? We're not going to do this minus 32 or plus 32 here first. We're going to do that last. And then we want to multiply it times the reciprocal. So we're going to say 9 on the top and 5 on the bottom. But then when we get done with all of that, we'll put that in parentheses, and then we'll subtract off that 32. Now we'll add 32, actually, to get the right number. And notice when I put in these numbers, I want everything to be a double, so it doesn't have any problems later on. And then we return that return value. So your return value in this case is the Fahrenheit temperature, not the Celsius temperature. Celsius comes in, Fahrenheit comes out. We also round that return value so it looks nice when we print it out. So what we can do in our tester then is we can say, okay, we can try some things like this. We can say double C temp this time. That's our Celsius temperature. And we're going to set that equal to 0. Our expectation is that when we convert that to Fahrenheit, we should get 32. And so we can copy this line of code and we're going to flip it over, because now we're going the other way. So you would say the Celsius temperature, so here we see Celsius temperature, and here we say C temp, right, because that's our Celsius temperature, that's the one we're using here, is, instead of F to C, we're going to call C to F. And we're passing in not the Fahrenheit temperature, no, the Celsius temperature. And the Celsius temperature is coming in, so the one coming out is Fahrenheit. So what I say is that it complains, right? Because it can't seem to find C to F. Did I misspell it? Let's go look and see. I called it C to F. It's right there. I wonder why it's having problems. C to F. We are loading it. Let's just try running it and see what happens. It says, nope, can't run it. When you get this, don't say run anyway. It doesn't make sense to run it. It's going to run the old version of it, and you've made a bunch of changes, and so it's not going to be useful. So we say cancel here. There's a problem. It's not seeing C to F. Is that an F? Should see it by now. Check over here. Did I call it wrong? C to F. Passing in C temp. Everything looks fine. F to C, C to F. Why can't it see it? Can you see the problem? I can't see the problem. Maybe if I say metric converter dot, that didn't work. Metric converter, because that's the name of the class. I can't see that. Oh, I see our problem. Okay. So C to F, right? Can't see it because here we're loading just that specific method. We're not loading the other one, importing the other one. If we want to get all the methods in this metric converter class, we can just put the star or an asterisk there, and this means everything in that metric conversion library we want, or package we want to load everything, all the different methods that belong there. Notice once we do that, that problem goes away. We should be able to run now. So let's try that. We see that Celsius temperature of 0 is equivalent to 32 in Fahrenheit. Yeah, 0 degrees in Celsius is 32 in Fahrenheit. Let's try a different number. Let's try 100. Right, we know that is the boiling point of water in Celsius. What is that in Fahrenheit? Well, the expectation is 212. Let's see if we get that. And we get 212, yes. We also did this one, 78, right? We found that that was 25.56. So if we put in as input 25.56 and then run it, we see we get, well, look there, we get 78.01. So we don't quite get 78.0. We're off by 100th. Why do you think that is? Well, remember, we rounded the number coming out. So we're going to be off by just a tiny little bit sometimes because of that rounding. It's called a rounding error. But I think that's close enough. For us, it's like, yeah, those are pretty much the same. We're off by 100th of a degree. That's really nothing to write home about. So saying, given what we're trying to do here, that's accurate enough. All right, so we've done the first two, but the rest of them are a little bit tricky. So let's just look at the assignment and see. I'm going to take a pause here real quick and see if everything's recording, and I'll come back. Let's see. All right, looking back here then, going back to what methods we have to provide. Let's look at that conversion class. Inches to and from centimeters, right? Let's try one of those. Again, you should be clear in your head about which way you're going. We're going inches to centimeters. So here in our metric converter, I'm using a round to be last since it's private. I'm going to put this in here. And I'm going to, let's write this. I'm going to maybe copy F to C. So I'm just copying it. And so I want to have the same kind of structure, but I'm going to switch it around a little bit. Instead of giving this a name, I'm just always going to say input. Okay, that's going to be our input. We're going inches to centimeters. I tend to like to use the full names for things. Inches to centimeters. Hopefully that's right. How do you spell centimeter? I think that's right. And we take the input. Now the input's going to be in inches, hopefully, right? This equation's not valid, so we can take that out. But what is the equation to convert? We can say return value here, or another way you could state this is you could say output. That's going to be our output. Whatever our output's going to be, that's going to be the return value. Okay. All right. Here, instead of return value, we're just going to call it output. And here we return that output once it's surrounded. Okay. So we're just changing that to output. Just trying to be really clear about what's input and what's output. Now, what's input here is inches, it seems. So what is the equation to do that? Well, that's a good question. Let's see if we can find the answer. All right, so our magic number to do this conversion is 2.54. We know that there's 2.54 centimeters per inch. So we're going to make a constant to remember that value. It might be nice to allow people from outside this class to find out these constants. So we're going to say public static final double. Yikes. We'll call this you could say, let's make it capitals, all capitals, num centimeters per inch. It's nice and clear, right? And then what is that value? Well, our value is 2.54. Okay? So that's called a scaling factor. We made it into a constant, which means it's not a variable. It's a number that does not change. We've given a name to it. What does this thing 2.54 represent? It represents the number of centimeters per inch. And we've made that public so that people outside of the class, if they need to get that number, they can just get it from the class directly. Say they're doing something else and just conversion. Okay, so now we're going from inches to centimeters. We know that there are 2.54 centimeters per inch. So let's do the equation. Well, the equation is pretty straightforward. Then you say, well, we take our input, which is inches, input, not capitalized, but input. So the input comes in as a parameter. So you take that input and we multiply it. Do we multiply or do we divide? Well, let's see. Are there more centimeters than there are inches? Like say, if we have 1 inch, how many centimeters is that? It's 2.54, right? So we'd have to multiply. So it gets bigger. The number gets bigger. The length doesn't, but the number does. So the answer does, the output. So we'd multiply then. That's the other thing. Whether to multiply or divide is another question. So say the input, which is inches, trying to get centimeters, so we multiply it times our constant num centimeters per inch. Okay. Now I can see really easily that we're just doing a multiplication here. And that will give us the number of centimeters per inch, and then we just take that output and we round it. So let's try it. Well, if we try it now, we say go and we run it. And we notice that, well, we didn't make a tester for it, so all we're still seeing is our old numbers. How do we go about testing it? So we go back to our tester then, and we're going to add another one of these tests. And say, well, let's say here, I copy this as an example and then paste it there. We're trying to go from inches to centimeters, so we're going to say, we'll just call this one inches. And how many inches are in a yard? I don't know. We know there's 12 inches in a foot, so maybe we say 12. And then we could look on a ruler if it has centimeters on it to see if we're accurate. So now that we say it's not a temperature anymore, you would say, maybe you put the variable first, you would say, you'd say inches to centimeters, right? And you would pass in, well, we just want to do the inches first, so we just say inches, right? So that would put inches on our output, or in the output window. When we say inches, and then we add word inches again, is the same as what? Well, the length in centimeters. So we'd say is the same as. Another way to say that is equal to. So inches is the same as. Then we do our equation. We say inches to centimeters. And we pass in as input our inches, because it needs to have inches. Then maybe we say plus, and then a spacing, we say centimeters. And the rest of this we don't need, so we're just going to go delete all that. We do need that parenthesis, I think. Let's see. I guess we need a closing double quote. So we're saying then system.out.println, however many inches is the same as those inches in centimeters, space centimeters. Hopefully we'll see what we hope for. So if we have a ruler and the ruler has centimeters on it, how long is the ruler going to be in centimeters? Let's try it. 12 inches is the same as 30.48 centimeters. Does that sound plausible? Well, we could just go to Google and find out. We could say 12 inches in centimeters. And we have a little conversion thing. And we get 30.48. Is that the answer we got? Let's find out. Yep, 30.48. 12 inches is the same as 3.48 in the 3.48 centimeters. Now, if you want to go the other way, so we go back here, and we want to go the other way now. We want to go from centimeters to inches. We could just copy this whole method again. Let's just do that. And again, when you're copying, there's this thing called pasting errors that come out and bite you sometimes because you copy and paste, but then you forget to change some of the things you need to change, because now we're going the other way. So we already have inches to centimeters. The compiler will complain. We want to go centimeters to inches. So we'll say centimeters to, and then this time inches. And our input, again, we have to think about it. Our input is going to be centimeters, as it says so right there. And it will return out the value of how many inches are in that number of centimeters. So here we have our output. That's what we're sending out. And then the only thing you have to do when you're using this conversion factor, you could go and look up what the number of inches per centimeter, right? And you can put that there. Or if you're smart, we already have this constant. So we can just divide. Instead of multiplying, we just divide by that constant, and then we'll get the output we want. So you only have to create one of these constants. The other one can be inferred just by dividing instead of multiplying. You have to think about it a little bit, but it does actually work. So now that we have this new method, we could do this, go to the tester now, and we see if we get back what we put in. What did we get? 30.48. So we could say double. This is our input value. We'll call it cm, I guess, for centimeter, equals, well, 30.48. We know that we should get 12 inches back if we do that, because we just did that conversion up here. Now we're just going back. And so now we take this line of code and we just change it to read. So it's from centimeters to inches. So we say here, we say cm, that's the name of our variable, cm. Instead of inches, we say centimeters. Is the same as, and we're not going inches to centimeters, we're doing centimeters to inches now. Centimeters to inches. We're not passing in inches, no, we're passing in centimeters, cm, I guess we're calling it. See, that's the name of our variable, we're passing that in. And then this should say inches, because now we're going the other way. Now the expectation is when I run this, I should get 12. for the number of centimeters or number of inches in 30.48 centimeters. Let's see if that's what I get. If I run it, yes, 30.48 centimeters is the same as 12 inches. And looks like, yes, that does work. We got back to where we started. So your challenge then on this assignment is to create all these methods. So you're going to have to figure out the conversion constant for each one of these, like inches to centimeters. We found like we only need to find one. We don't have to do centimeters to inches because we just divide instead of multiply. Same thing for miles to kilometers. You can just divide and get kilometers to miles. Here's ounces to grams and pounds to kilograms. You need to do all of these. Use the pattern we talked about, right? We changed this to input, I guess. So we're making it a little bit more generic, but the name of the parameter doesn't really matter much. So going back to our code, what you have to do is add all those metric conversion routines here using these patterns as a guide, and then here in your tester, make sure to test each one of those. Now I'm going to be testing this as well, but I'll have different numbers. And I'm going to use your class. I'm not going to use your tester though. I'm going to use my own tester. I'm going to see if how accurate your conversion functions are. I'm not going to tell you what the data is. These should work with any values going in. So I'm going to just make wacky data that's looking for certain numbers. And if I don't see those numbers, I'll go back and check and see what might have happened. Realize that all these numbers coming out have to be rounded, and we're doing that before we send it back, right? If we go here, trying to get in there. See how we round everything before we send it back, before we return it. So make sure to add all those methods here, and in your tester class, include a test for that to make sure you're getting accurate results. That's for your testing. My testing will be a little bit different. All right, I hope this was helpful. And now we have this, when we're all done, we'll have this new library that will help us do our conversions from metric to English standard measure and then back again. Should be really handy. All right, thanks for listening.